This podcast was created as a supplemental learning resource for this course. The content is based on assigned course materials, including open educational resources, textbook chapters, instructor-developed explanations, examples, and applications connected to course topics. AI tools were used to help transform course material into a conversational podcast format, including the use of AI-generated narration. The AI narration is intended to make the material more engaging, accessible, and flexible for students. However, the podcast should not replace careful reading of assigned materials, reviewing course lectures, or completing course activities. Any interpretations, examples, or explanations included in the podcast are provided for educational purposes and are the responsibility of the instructor. Students should rely on the assigned readings, course lectures, and official course materials as the primary sources for exams, assignments, and class discussions.
Usually, like when we talk about a medical diagnosis or measuring something in the hard sciences, there's this underlying expectation of just, total undeniable precision.
Right, yeah, it's absolute.
Yeah, like you break your arm, the x-ray shows that jagged white line fracturing the bone, and the doctor just points to the screen. It's visible, it's concrete, and honestly, it's comforting. We're wired to like things that can be categorized and put into neat little boxes.
Absolutely. I mean, that physical reality provides a huge sense of security. You can literally point a machine at a femur and measure its exact length down to the millimeter. There is zero debate about whether the bone is broken or, what the bone even is. The measurement is a direct observation of a physical property.
But then you step into the world of psychology, you step into the human mind, and suddenly that x-ray machine is completely useless.
Yeah, throw it out the window.
Right. We're looking at a landscape that is just incredibly murky. I mean, I can't take an x-ray of someone's self-esteem. I can't draw blood to see if someone is an introvert.
And that right there is the absolute definition of diagnostic muddy waters. It presents the central, fundamental challenge of the entire psychological field. I mean, if science requires measurement, but the things we are studying are totally invisible, how do we proceed?
Which brings us to the core of what we're doing today. So welcome to this deep dive, specifically tailored for you, the undergraduate psychology student.
Welcome, everyone.
We are diving into the complex, sometimes frustrating but always fascinating world of Chapter 4 of your Research Methods textbook, which is all about psychological measurement.
And this is huge. Without a solid grasp of this chapter, literally none of the theories or studies you'll encounter in your degree will make structural sense.
Yeah, that's so true.
If you don't understand how researchers measure the invisible, you just cannot critically evaluate their findings.
Right. But before we really get into the weeds here, a quick disclaimer for you listening. This audio overview is designed to be your learning companion. We're here to help you digest these really dense methodological concepts, to connect the dots and, to hopefully make the abstract feel tangible.
Exactly.
But this is not a replacement for actually reading Chapter 4. You still have to engage with the text, look at the charts, do the heavy lifting yourself.
Yeah, think of this conversation as a conceptual roadmap. We can highlight the treacherous turns and the major landmarks for you, but you still need to walk the path yourself.
Well said. So let's start with a scenario that perfectly illustrates this whole measurement problem. Your textbook opens with a hook from this 2002 study by McDonald and Martineau.
Oh, yeah, classic example.
Right. So the researchers were looking into a very real, very consequential human behavior. They wanted to know if a female university student's mood affected her intention to have unprotected sex. And they were specifically looking at students who had low self-esteem.
And when you look at that study through the lens of a research methodologist, it is a brilliant piece of empirical design. But it also highlights a massive logistical nightmare.
How so?
Well, the researchers had to measure 3 distinct variables. First, they needed a baseline understanding of the participants' self-esteem.
Okay.
Second, they needed to actively manipulate the participants' mood by having them focus on negative thoughts, which means they also had to prove that the mood was actually altered.
Right, you can't just assume they got sad.
Exactly. And third, they needed to measure the participants' intentions to engage in risky sexual behavior in the future.
And every single one of those variables, mood, self-esteem, future intentions, they're all invisible. They're ghosts. You can't put intention on a bathroom scale.
Right.
You can't wrap a tape measure around a bad mood.
No, you're trying to capture a snapshot of a fleeting internal state of mind or, a deeply ingrained belief system. This is the barrier every psychologist faces. Like,
Yeah.
how do you objectively, scientifically measure something that only exists within the subjective experience of the participant?
And the textbook basically spends the entire chapter answering that exact question, proving that it is actually possible to do it.
Hmm.
So today we're going to explore what measurement in psychology fundamentally entails, moving way beyond physical tools.
Mm-hmm.
We're going to break down the concept of a construct, which is that invisible thing we're trying to catch.
We also have to tackle the underlying mathematics, which I know sounds scary, but it's vital.
Oh yeah, the math.
We'll look at the 4 levels of measurement. It's a system that dictates exactly what statistical gymnastics you are legally allowed to perform on your data.
Right. And then we'll separate 2 ideas that people constantly confuse: reliability and validity. We'll look at why a tool can be perfectly consistent without actually being accurate.
Yeah, that's a huge trap for young researchers.
Totally. And finally, we'll look at how you, as a student researcher, can actually apply all of this when you're designing your own studies.
So the journey goes from the highly theoretical philosophy of science, like all the way down to the practical reality of handing a survey to a participant.
Let's focus on that first hurdle then. We all know what it means to measure weight or height, but what does the word measurement actually mean in a psychological context? Because it clearly isn't about physical instruments.
Right. So broadly speaking, the scientific definition of measurement is the systematic assignment of scores to individuals, so that those scores represent some characteristic of the individuals.
The key word there being systematic, right?
Exactly. The systematic nature is what separates measurement from just guessing. It does not require a physical tool. What it requires is a rigid procedure.
Give me an example.
Consider a cognitive psychologist trying to measure working memory capacity. Working memory is like your brain's RAM, right?
Yeah.
It's your ability to hold and manipulate several pieces of information all at once.
Yeah, like doing math in your head.
Right. Now, they can't look inside your brain to physically see the RAM, so they use a backward digit span task.
Oh, I remember doing one of these. The researcher reads a list of numbers like 7, 2, 9, 4, and you have to repeat them back in reverse order. So 4, 9, 2, 7.
Yes. And the systematic procedure dictates that the researcher keeps increasing the length of the list until you make an error.
Okay.
So the length of the longest list you can successfully reverse becomes your score. That numerical score systematically represents your invisible working memory capacity. The psychologist just performed a rigorous measurement without a single physical instrument.
That makes total sense.
Mm-hmm.
And clinical psychology does this all the time too, right? If a therapist is trying to gauge the severity of the patient's depression, they don't just ask, hey, how sad are you, and then guess a number.
No, that would be terrible science.
Right. They use something highly structured, like the Beck Depression Inventory.
Exactly. The Beck Depression Inventory is a 21-item self-report questionnaire. The patient rates their experience of various symptoms over the past 2 weeks. Symptoms like, a loss of energy, changes in sleep, or feelings of guilt.
And then you just add it all up.
Yep. The sum of those 21 individual ratings becomes the total score. That final number systematically represents their current level of depression.
So measurement in this field is really an act of translation. You're translating the invisible internal experience into a visible external score.
That's such a great way to put it.
And that invisible thing we're translating, that's what psychologists call a construct.
Yes, the construct. And that term will follow you through your entire academic career. A construct is a variable that cannot be directly observed. It's a psychological concept that represents behavioral tendencies or complex patterns of internal processes.
So like extroversion is a construct, math anxiety is a construct, job satisfaction, fear, athleticism, political conservatism.
All constructs. None of them possess mass or occupy physical space. You can't just look at a person and accurately read their precise level of extroversion the way you can read their eye color.
Right. And the textbook uses a famous framework to illustrate this, which is the Big Five personality dimensions. Let's really look at how psychologists built this massive construct, because it wasn't just a random guess, right?
Oh, not at all. The Big Five is a masterclass in conceptualizing broad constructs. It took decades of research, cross-cultural studies, and intense factor analysis for psychologists to identify 5 broad dimensions that basically capture the vast majority of human personality variation.
And people often use the acronym OCEAN for that, right?
Mm.
Openness to experience, conscientiousness, extroversion, agreeableness, and neuroticism.
That's the one. But here's the thing, calling someone extroverted is still incredibly vague.
Right. I mean, if I say my friend is an extrovert, I mean she talks a lot? Or do I mean she likes going to really loud parties? Or do I just mean she's, generally warm to strangers?
Yeah.
Because those are very different behaviors.
Exactly, which is why researchers like Costa and McCrae realized that these broad dimensions had to be broken down even further to be scientifically useful. They defined each of the big 5 dimensions in terms of 6 highly specific subconstructs, which they call facets.
So extroversion isn't just a monolith.
Far from it. The broad construct of extroversion actually comprises 6 distinct facets: warmth, gregariousness, assertiveness, activity level, excitement seeking, and positive emotions.
Oh, wow. So you could be high in one but low in another.
Exactly. A person might score incredibly high on warmth and gregariousness, but really low on excitement seeking, meaning, they love deep conversations with friends, but they would absolutely hate skydiving.
That's so relatable.
Right. By measuring all 6 specific facets individually, researchers build a highly nuanced, comprehensive picture of the overarching construct.
I can imagine a student listening to this and wondering, why do psychologists make it so difficult? Why do we need to invent all these specific facets and complex scientific definitions?
It's a fair question.
If I want to measure self-esteem in a study, why can't I just look up self-esteem in the Merriam-Webster dictionary, put that definition in my paper, and just move on?
Because the dictionary is built for everyday communication. It's not built for scientific rigor. Everyday language is packed with colloquialisms, overlapping meanings, and just really vague assumptions.
So it's too messy.
Way too messy. If you look up intelligence in a standard dictionary, you're going to find a definition that is far too broad to build an empirical study around. Furthermore, many vital scientific constructs like working memory capacity or cognitive dissonance, they don't even exist in a standard dictionary.
So researchers have to forge their own definitions. They have to create what the text calls conceptual definitions.
Yes. A conceptual definition is an exhaustively detailed description of the specific behaviors and internal processes that constitute the construct. And it also explains how that construct theoretically relates to other variables.
It creates a boundary, basically.
Exactly. It tells other scientists exactly what is included in your version of the concept and exactly what is excluded.
And those boundaries aren't permanent, right? A conceptual definition can actually evolve or be completely rewritten over time.
Science is always self-correcting. If an older conceptual definition no longer aligns with new empirical data, it gets revised or discarded.
Like what?
Well, the conceptual definition of autism, for example, has undergone massive fundamental shifts over the past 50 years as researchers gained a deeper understanding of neurodivergence. When you read older research literature, you will often find conceptual definitions that seem completely alien to modern psychology.
That's a great example. Let's do a quick thought experiment here.
Yeah.
To you, listening right now, I want you to think about the construct of intelligence. How would you formally, conceptually define it if you were the lead researcher on a multi-million-dollar grant?
It's harder than it sounds.
Right. What goes inside your boundary? Is it strictly the ability to solve abstract logic puzzles? Does it include social navigation and, reading a room? Does it include this speed of processing information or just the sheer volume of memorized facts?
And whatever boundary you draw with your conceptual definition, that will entirely dictate how you attempt to measure it.
And drawing that boundary leads us to the next massive hurdle, because possessing a crystal clear conceptual definition in your mind is entirely useless if you don't have a physical mechanism to actually extract data from the real world.
Yeah, you have to build a bridge from the abstract concept to a concrete operation. This is where we need an operational definition.
Operational definition. Okay, break that down.
The operational definition is the precise, practical procedure you will use to measure the variable in your specific study. It takes the unobservable construct, like your highly detailed conceptual definition of intelligence, and transforms it into a visible, recordable, and quantifiable event.
Okay, so making it real. And the textbook categorizes these operational definitions into 3 distinct buckets. The first category is probably the most common one you see in psychology: self-report measures.
Right. This relies on the participant's ability and willingness to report on their own internal states. The participant acts as the observer of their own thoughts, feelings, or past actions.
Like the Rosenberg self-esteem scale we mentioned.
Exactly, a classic example. The researcher doesn't try to guess your self-esteem by analyzing your body language or anything. They just ask you.
Right, you're presented with a statement like, I feel that I'm a person of worth, at least on an equal plane with others. And then you have to choose a rating. strongly agree, agree, disagree, or strongly disagree.
And in that specific study, the operational definition of the construct self-esteem is literally the mathematical sum of the participants' ratings on that specific questionnaire. Nothing more, nothing less.
But the limitation there is pretty obvious, isn't it? Self-reporting requires humans to be honest and self-aware, and we know humans are frequently neither.
That's the understatement of the year. People suffer from social desirability bias. They want to look good to the researcher, or they genuinely just lack the introspection to know how they actually feel.
So if self-report is flawed, we move to the second bucket, behavioral measures.
Right. With behavioral measures, we bypass asking the participant for their opinion entirely. Instead, the researcher observes and records specific, predefined aspects of their actual behavior.
And this can happen in a lab or out in the real world, right?
Exactly. It can occur in a tightly controlled laboratory environment or out in the wild through naturalistic observation.
The textbook highlights one of the most famous and definitely somewhat controversial studies in the history of psychology for this, Albert Bandura's Bobo doll experiment.
Oh, yes.
So Bandura was investigating the construct of aggression in young children.
And asking a 4-year-old to self-report their baseline level of aggression on a numbered scale is scientifically useless. You can't just ask a toddler on a scale of 1 to 10, how aggressive are you feeling?
Right. I'm a strong 7 today, doctor. So Bandura needed a purely behavioral operational definition. He placed children in a room containing various toys, including this large, inflatable clown punching bag known as a Bobo doll. And the children were observed for a 20-minute period.
But the key here is that the researchers weren't just taking subjective notes. They didn't just write down on a clipboard. The child seemed very angry today.
Yeah, that leaves way too much room for interpretation.
Way too much. The operational definition had to be rigidly specific to eliminate researcher bias. So the researchers tallied specific, clearly defined acts of physical aggression.
Like what?
They counted the exact number of times a child hit the Bobo doll with a wooden mallet. They counted the number of times the child punched the doll in the nose. They counted the number of times the child kicked the doll across the room.
Wow, okay, so very specific actions.
Very specific. The total frequency of those highly specific acts during that 20-minute window became the operational definition of aggression.
They took a complex internal emotional state and made it visible by literally counting mallet strikes.
That's wild. Now, the third category shifts away from behavior and looks inward. Physiological measures.
Right. Many psychological states trigger involuntary biological responses. By recording these physiological processes, researchers can gather objective data that the participant cannot easily fake or suppress.
Like if I'm terrified, I might try to hide it and keep a straight face, but I can't stop my palms from sweating.
Exactly. That phenomenon is known as the galvanic skin response, which measures changes in the electrical conductivity of the skin due to sweat.
That's basically lie detector tech, right?
Part of it, yeah. Other physiological operational definitions include tracking heart rate, monitoring blood pressure, analyzing saliva for hormone levels like cortisol, or even utilizing functional magnetic resonance imaging fMRI to map electrical activity and blood flow in specific cortical regions of the brain.
But here's the friction I see. If I want to measure a massive construct like stress, I have options from all 3 buckets.
You do. I could use a self-report survey and ask them how stressed they feel. I could use a behavioral measure and count how many times they bite their nails in a waiting room. Or I could use a physiological measure and draw their blood to check their cortisol levels. With all these options, how does a researcher know which operational definition is the correct one?
That's the million-dollar question. And the scientific reality is that no single operational definition is perfect. Every single one has flaws.
Okay, so what do we do?
Well, self-reports are prone to lying. Nail biting might just be a bad habit, not stress. And a cortisol spike could be caused by exercise, not anxiety. Because of these inherent flaws, psychologists rely on a vital strategy called converging operations.
Converging operations. It sounds like multiple teams tackling a problem from different angles.
That is precisely the logic. Instead of trusting a single flawed measure, researchers intentionally use multiple distinct operational definitions for the exact same construct within a study or across a series of studies.
Give me an example of how that works in practice.
Okay, returning to the construct of stress. Researchers might deploy the Holmes and Raw Facial Readjustment Rating Scale.
That's the life events checklist, right? Where you self-report major life changes over the past year. Like a divorce is weighted at 73 points, getting fired is 47 points, changing your residence is 20 points?
Exactly. So that's one angle. Alongside that, they might administer the hassles and uplifts scale, which ignores those major life events and focuses on the frequency of everyday micro annoyances, traffic, losing your keys, that sort of thing.
Okay, so 2 different self-reports.
Then they might add the perceived stress scale, which directly asks participants to rate their subjective feelings of nervousness and lack of control.
So that's 3 entirely different self-report angles on stress.
Right. And to anchor it in biology, they collect a saliva sample to measure cortisol. So now the researcher has 4 completely separate operational definitions generating data.
That's a lot of data.
The power of converging operations is revealed when you analyze the relationships between those data sets. If the participant who scores through the roof on the Holmes and Rahe life event scale also reports high daily annoyances, expresses subjective nervousness, and exhibits elevated cortisol, those diverse operations are converging on a single reality.
I see. All the compass needles are pointing to the exact same magnetic north.
Beautifully said. When multiple independent operational definitions strongly correlate, the scientific community gains immense confidence. It provides robust evidence not only that the measurements are effective, but that the underlying construct of stress is a genuinely useful framework for predicting human outcomes.
And what if they don't match up?
If the measures completely contradict each other, it forces the researchers to reconsider their conceptual definition entirely. Something is fundamentally wrong.
Okay, so we establish the concept, we build the operational tools, and finally we collect the numbers. We have our data points, which introduces a completely different set of problems. We need to talk about the math.
Ah, yes, the math. The assumption many people make is that a number is just a number. If you have a spreadsheet full of digits, you can just plug them into a calculator and find the average.
Right.
In psychological measurement, that assumption will destroy your research. The mathematical nature of the scores you collect dictates absolutely what statistical tests you are permitted to run.
And the textbook introduces a foundational system developed by S.S. Stevens in 1946. He formalized 4 levels of measurement, which are also known as scales of measurement. I know students often struggle to keep these straight, so let's dismantle them carefully.
That was good.
The 4 levels are nominal, ordinal, interval, and ratio. You can remember them with the acronym NOIR. Let's start at the absolute baseline. Level 1, nominal measurement.
Nominal measurement is applied to categorical variables. Honestly, the term measurement is almost too strong here. The scores assigned are merely category labels. The only information these labels transmit is whether 2 individuals are identical or distinct regarding the measured variable.
So if a survey asks for your marital status, single, married, divorced, widowed, or due, those categories are nominal. The same applies to your college major, your ethnicity, or your favorite genre of music.
Exactly. The defining characteristic of nominal data is the complete absence of a logical hierarchy. There is no mathematical or scientific justification for claiming that a psychology major is quantitatively higher or placed ahead of an English major. They're exclusively different.
Because there's just labels, the math we can do is severely restricted, right?
Extremely restricted. You cannot calculate a mean. Averaging single and married does not produce a mathematically meaningful number.
Right. What's the average of single and married? It doesn't exist.
Exactly. The only statistical measure of central tendency available for nominal data is the mode, the most frequently occurring category. You can state the mode of our sample was single, meaning it was the most common response. That is the absolute limit of your analysis.
Okay, so moving one step up the hierarchy brings us to level 2, ordinal measurement. And this introduces the concept of rank order.
Yes, ordinal measurement conveys directionality. It tells us that a participant is higher or lower, faster or slower, more or less than another participant. However, it introduces a dangerous blind spot. It does not communicate the magnitude of the difference between the ranks.
Let's visualize a marathon to expose this flaw. We have the first place finisher, the second place finisher, and the third place finisher. Those ranks 1, 2, and 3 are ordinal data. We know with absolute certainty that the first place runner was faster than the second place runner.
But the data is completely blind to the time gap. The first place runner might have beaten the second place runner by a fraction of a millisecond in a photo finish. Meanwhile, the second place runner might have beaten the third place runner by 45 minutes.
Oh, wow.
The ranks are evenly spaced mathematically, 1, 2, 3, but the physical reality they represent is wildly uneven.
And psychologists use ordinal scales constantly with satisfaction surveys, don't they?
Yeah.
Like a participant rates a therapy program as very dissatisfied, somewhat satisfied, or very satisfied.
All the time. And there is an undeniable logical progression there. Very satisfied implies a greater degree of satisfaction than somewhat satisfied, but the psychological terrain between those options is unknown.
What do you mean?
Well, the emotional leap a person has to make to go from very dissatisfied to somewhat dissatisfied might be massive, while the shift from somewhat satisfied to very satisfied might be trivial. We just don't know.
Because the distance between the ranks isn't standardized. So calculating a true mean is mathematically inappropriate here too.
Correct. You can use the mode, and because the data is ordered, you can locate the median, the exact middle value in the sorted list. But averaging ordinal ranks creates a fictional midpoint that doesn't correspond to reality.
This limitation was a driving force behind Stevens' work, right? Psychologists desperately wanted to use powerful statistical tools, which required a higher level of precision. And that brings us to level 3, interval measurement.
Yes, at the interval level, the distance between the points on the scale is guaranteed to be standardized and equal.
That's a good everyday example of that.
The classic illustration outside of psychology is temperature measured in Fahrenheit or Celsius. The physical difference in thermal energy between 30 degrees and 40 degrees is physically identical to the difference between 80 degrees and 90 degrees. Every single 10-degree increment represents the exact same change in the underlying physical property.
But interval scales contain a very specific, somewhat counterintuitive mathematical limitation. They lack a true 0 point.
They do.
Let's use IQ as an example. Let's say I take a standardized intelligence test and score a 140. A friend takes the same test and scores a 70. The intervals are equal, so the 70-point gap is meaningful. But can I claim that I am exactly twice as intelligent as my friend?
Absolutely not. The mathematics forbid it. IQ operates on an interval scale, and a true 0 point signifies the absolute total absence of the property being measured.
Right.
An IQ score of 0 does not represent a biological organism with an absolute absence of intelligence. It is simply an arbitrary anchor point on a statistical distribution.
Just like 0 degrees Fahrenheit doesn't mean there is zero heat in the universe. It's just really cold.
Exactly. Because the 0 point is arbitrary, constructing ratios is invalid. You cannot make twice as much or half as much comparisons. You can confidently state that the point difference between an IQ of 80 and 100 is equivalent to the difference between 120 and 140. You can legitimately calculate a mean because the intervals are standardized, but you cannot compute ratios.
Okay, so to unlock that final mathematical door, we need level 4, ratio measurement. This is the apex of Stevens' system. It includes categorical labels, it possesses rank order, it guarantees equal intervals, and crucially, it features a true, meaningful 0 point.
At the ratio level, 0 translates to nothing. If we look at the Kelvin temperature scale, 0 Kelvin is absolute zero, the theoretical state where all molecular kinetic energy ceases. It is a true absence of heat.
And in psychology.
In psychological research, common ratio variables include age in months, the number of siblings a participant has, or reaction time in milliseconds.
If a participant's reaction time to a visual stimulus is 0 milliseconds, that means there was literally no time delay. It's a true 0. And because of that, if participant A takes 400 milliseconds to respond, and participant B takes 200 milliseconds, I can mathematically state that participant A took exactly twice as long.
Yes. Ratio scales grant you access to every statistical operation available. You can calculate the mean, the median, the mode, and you can form valid proportions and ratios.
Let's do a quick pause and think for the students listening to solidify this. Imagine you are reading a study where the researchers counted the total number of times a participant visited a mental health professional over a 5-year period. Which of the 4 NOIR levels, nominal, ordinal, interval, ratio, does that variable represent?
The diagnostic question to ask yourself here is, does the scale have a true 0? Is it physically possible for a participant to record 0 visits? And does that 0 signify the complete absence of the behavior?
Well, since a person can absolutely visit a therapist 0 times, the variable operates at the ratio level. Recognizing these levels isn't just trivia. It is the firewall that prevents researchers from applying incorrect statistical formulas and publishing invalid conclusions.
Exactly. You can have the most advanced operational definition in the world, but if you treat ordinal data like ratio data, your entire study collapses. The math won't save you if you apply the wrong rules.
Okay, so we have translated our invisible construct into a concrete operation, and we know exactly what mathematical level our data occupies. Now we confront the most terrifying question a researcher faces. How do we know the tool we built isn't fundamentally broken? Like, how do we prove that the data we are generating is actually worth analyzing?
Right. This moves us into the domains of reliability and validity. These are two distinct, non-interchangeable concepts, and confusing them is a hallmark of bad science.
So true.
Let's tackle reliability first. In science, you cannot afford to trust your instruments blindly. You must interrogate them.
The textbook offers an analogy that every student should just memorize. Imagine you commit to a strict diet and exercise regimen. After a month, the physical evidence is undeniable. Your clothes fit loosely, your energy levels are way up, and friends are commenting on your weight loss. You feel a massive difference.
Okay, setting the scene.
But then, you step onto your bathroom scale, and the digital display insists you have gained 15 pounds.
So confronted with that conflicting data, what is your conclusion? Do you discard all the other physical evidence and just accept the scale's verdict?
Never. You conclude that the internal mechanism of the scale is broken. You reject the measurement because the tool failed to produce a result consistent with reality. It's an unreliable instrument.
Spot on. In the context of psychological methodology, reliability specifically refers to the consistency of a measure. An instrument is reliable if it yields consistent results when the underlying reality remains consistent. Psychologists require empirical proof of this consistency, and they examine three specific manifestations of reliability.
The first manifestation is test-retest reliability. This looks at consistency across time.
Right. If you are attempting to measure a psychological construct that theories suggest is relatively stable, such as adult intelligence, or a core personality trait like conscientiousness, then a participant's score should not experience wild, erratic fluctuations from week to week.
Makes sense.
If a participant tests in the 90th percentile for intelligence on a Tuesday, they should theoretically test very close to the 90th percentile the following Tuesday, assuming no brain injury occurred.
The textbook cites the Rosenberg self-esteem scale again here. If researchers administer that scale to a cohort of college students, wait a week, and administer the exact same scale to the exact same students, the statistical correlation between the two sets of scores is approximately plus 0.95.
And just for context, a correlation coefficient ranges from -1 1.0 to plus 1.0. A correlation of plus 0.95 is extraordinarily high. In the field, a test-retest correlation of plus 0.80 or above is generally accepted as robust evidence of temporal consistency. The tool is dependably capturing the same signal over time.
But we need to introduce a major caveat here. A lack of test-retest reliability doesn't always mean the tool is broken. It depends entirely on what construct you are measuring.
Absolutely.
If I take a survey measuring my current mood, and I score high on joy today, but next week my dog gets sick and I score high on despair, the survey isn't broken.
Exactly the opposite. A valid mood survey should demonstrate low test-retest reliability over long periods because the construct of mood is inherently volatile. You only expect temporal consistency when measuring stable traits.
Okay, that makes sense.
Which brings us to the second manifestation, internal consistency. This applies to multiple item measures, such as a 30-question personality inventory.
If a survey claims that all 30 of its questions are measuring the singular construct of assertiveness, then a participant's responses to those individual questions should logically align with one another. Like, if a participant strongly agrees with the statement, "I frequently take charge in group settings," they should also agree with, "I am not afraid to voice a dissenting opinion."
Right. If a participant's answers resemble a random scatter plot agreeing with statements that directly contradict each other, the instrument lacks internal consistency. The items are not pulling in the same conceptual direction.
So how do you prove it mathematically?
To mathematically prove internal consistency, researchers utilize a split-half correlation.
Which is exactly what it sounds like.
Yeah.
You literally slice the test down the middle, you calculate a participant score using only the even-numbered questions, and then calculate a separate score using only the odd-numbered questions. If the test is internally consistent, those two half scores should correlate strongly.
Exactly. But the gold standard for internal consistency, a statistic you will encounter in almost every methodology section you ever read, is Cronbach's alpha.
Oh man, let's unpack the math behind Cronbach's alpha because it is brilliant. It takes the split-half concept to its absolute logical extreme.
It is a profoundly elegant statistical solution. Imagine a brief 10-item questionnaire. If you wanted to test its internal consistency using the split-half method, you could split it in half by odd and even numbers, like you said. But what if you split it by the first 5 and the last 5? What if you randomly selected 5?
There are a lot of ways to split it.
Mathematically, there are 252 unique ways to divide a 10-item test into 2 equal halves.
And Cronbach's alpha doesn't just pick one split. Conceptually, it calculates the correlation for all 252 possible split-half combinations, and then calculates the mean average of all those correlations. It is an exhaustive, mathematically rigorous test of how well every single item plays together.
I love that you're geeking out over that. It really is elegant. And similar to retest reliability, researchers look for a Cronbach's alpha value of plus 0.8 or higher to confidently declare that a multiple item measure is internally consistent.
So that's time and items. What's the third?
The final type of consistency is inter-rater reliability. This becomes paramount the moment human judgment is introduced into the operational definition.
Let's revisit Bandura's Bobo doll room. We operationalized aggression as the number of times a child strikes the doll with a mallet. But what if the researcher watching the video monitor blinks and misses a strike? Or worse, what if a child lightly taps the doll with the mallet and researcher A counts it as a hit, but researcher B thinks it was just an accidental brush?
This happens all the time. Human observers are prone to fatigue, distraction, and subjective interpretation. To counteract this, rigorous studies employ 2 or more independent observers who evaluate the exact same behavior without communicating with each other.
Okay.
Inter-rater reliability is the statistical measure of how closely those independent judgments align. If observer A records 15 aggressive acts and observer B records 16, the inter-rater reliability is excellent. If observer A records 15 and observer B records 4, the operational definition is fatally ambiguous.
The researchers have to go back and explicitly define what constitutes a hit.
Exactly. Now, the math used to calculate this agreement depends on the NOI level of the data. If the observers are generating quantitative data, like counting the frequency of hits, researchers often use Cronbach's alpha. But if the observers are generating categorical nominal data, like deciding if a behavior falls into the category of playful or aggressive, they use a statistic called Cohen's kappa.
And the broader scientific context here is really critical for students to grasp. The field of psychology has been grappling with a replication crisis, where classic studies fail to produce the same results when they're repeated.
Yes, it's a big deal.
And a significant contributor to that crisis is poor reliability. If a researcher's tools aren't consistent over time across items or between observers, the resulting data is essentially just statistical noise. You cannot build a cumulative science on unreliable foundations.
Could not agree more.
So, let's say we have proven our tool is reliable. It is perfectly consistent. Are we ready to publish?
Not even close.
Right, because we haven't proven validity. And this is where my absolute favorite textbook analogy comes into play.
Oh, I know the one. The index finger hypothetical.
Exactly. Let's say I approach you and claim I have engineered a revolutionary, frictionless way to measure a person's self-esteem. I bypass self-report surveys entirely. Instead, I take out a standardized metric ruler and I measure the exact length of your right index finger in centimeters.
From a reliability standpoint, your method is flawless.
Right. It has perfect retest reliability. If I measure your finger today, it's 8.2 centimeters. Next week, it's still 8.2 centimeters. It has perfect inter-rater reliability. If another researcher uses the ruler, they will also get 8.2 centimeters. The consistency is absolute.
Yet the measurement is entirely, completely scientifically useless.
Because the length of an index finger has absolutely zero connection to a person's psychological sense of self-worth. A measurement tool can be perfectly, immaculately reliable while completely lacking validity. Reliability asks, is the tool consistent? Validity asks, is the tool actually measuring the specific construct it claims to be measuring?
That's the difference right there. Validity is the pursuit of accuracy. And unlike reliability, which can be neatly calculated with a single statistic like Cronbach's alpha, validity is a complex argument. Researchers have to build a multifaceted case proving their measure is accurate, typically relying on 4 distinct types of validity evidence.
And the first type is the most intuitive, but also the weakest. Face validity. This simply asks, does the measurement tool look like it measures the target construct on the surface, on its face?
Right. If a self-esteem inventory asks the question, do you generally feel good about yourself? That item possesses high face validity. It aligns with basic common sense. Your index finger ruler, on the other hand, possesses zero face validity for measuring self-esteem.
But the textbook emphasizes that face validity is incredibly flimsy evidence. Just because a survey looks obvious doesn't mean it operates accurately in the real world. In fact, some of the most robust psychological tools rely on questions that seem completely bizarre on their face.
Oh, totally. A prime example is the Minnesota Multiphasic Personality Inventory, or the MMPI-2. It is a massive, highly validated assessment used extensively in clinical psychology, and it contains items that appear entirely disconnected from mental health.
Like what?
Like asking participants to agree or disagree with the statement, "I enjoy reading detective or mystery stories."
Wait, really? If I am evaluating a patient for severe psychopathology, a question about mystery novels seems absurd. It completely lacks face validity.
But the developers of the MMPI didn't care about face validity. They cared about empirical data. Through exhaustive testing, they discovered that specific clinical populations, such as individuals who tend to heavily suppress aggressive impulses, consistently answer that specific question differently than the general population.
Wow.
The item works mathematically, even if it looks nonsensical. Conversely, a survey might look perfectly valid on its face, but fail miserably when actually tested. Face validity is merely a superficial starting point.
So, the second layer of evidence requires a deeper structural analysis. Content validity. Let's say I'm trying to measure the construct of job satisfaction. I create a survey with high face validity. I ask, do you like your desk? And do you enjoy the coffee in the break room? Both questions are clearly about the job.
But you are failing to capture the totality of the conceptual definition. If job satisfaction is theoretically defined as encompassing compensation, management relations, daily tasks, and work environment, your survey only measures a tiny fraction of the construct.
I missed salary and management entirely. Therefore, my survey lacks content validity. It doesn't cover the full scope of the concept. It's an incomplete net.
Exactly. To prove content validity, researchers must systematically map their operational measure against every single facet of their conceptual definition, ensuring no theoretical territory is left unexamined.
Okay, that makes sense.
The third type of evidence, criterion validity, shifts the focus from the internal structure of the test to its relationship with the external world.
This is where the rubber really meets the road. Criterion validity demands that your new measurement tool empirically correlates with other variables known as criteria that it theoretically should correlate with.
Right. If you develop a novel questionnaire designed to measure test anxiety, how do you demonstrate its validity? You identify a logical, real-world criterion. Individuals who suffer from severe test anxiety should, theoretically, perform worse on high-stakes examinations.
So if you administer your questionnaire and find a strong negative correlation between high test anxiety scores and actual exam grades, you have established criterion validity.
Yes. And researchers look at a few subtypes here. If I administer the test anxiety survey today and look at the students' exam grades from today, that is called concurrent validity because the measurement and the criterion occur simultaneously.
Okay.
But if I administer the survey on the first day of the semester and use those scores to successfully predict who will fail the final exam 3 months later, that is predictive validity.
A particularly crucial component of this process is convergent validity. This involves correlating your new untested instrument with existing, heavily validated measures of the exact same construct.
The textbook highlights the development of the Need for Cognition scale by researchers Cacioppo and Petty. This construct measures the extent to which individuals inherently value and enjoy engaging in effortful, deep cognitive processing.
Some people love complex puzzles, others despise them.
Exactly. When Cacioppo and Petty introduced this scale, they carried the burden of proof. To establish convergent validity, they administered their new scale alongside standardized academic achievement tests.
What was the logic there?
The underlying logic was that individuals who inherently enjoy deep thinking should naturally perform better on complex academic assessments. The resulting strong positive correlation provided robust convergent validity evidence. Their new tool was pointing in the same direction as established educational metrics.
But pointing in the right direction isn't enough, is it? You also have to prove you aren't accidentally pointing at the wrong thing. That is the fourth and final piece of the puzzle. Discriminant validity.
Discriminant validity is the critical inverse of convergent validity. You must empirically demonstrate that your measure does not strongly correlate with constructs that are conceptually distinct.
Let's use our self-esteem and mood problem from earlier. Self-esteem is conceptually defined as a stable, enduring trait. Mood is defined as a transient, temporary state. If I invent a new self-esteem survey, I have to prove discriminant validity by showing that my participants' scores do not radically fluctuate in tandem with their daily mood.
If your self-esteem scores show a massive plus 0.90 correlation with a basic mood survey, the scientific community will just reject your tool. They will argue that you haven't invented a self-esteem measure at all. You have merely invented a very complicated way of asking people if they're having a good day.
Right.
Cacioppo and Teddy faced this exact challenge with their need for cognition scale.
They had to prove that enjoying deep thinking wasn't just another flavor of test anxiety. They established discriminant validity by proving that scores on their new scale had no significant correlation with established measures of test anxiety. They proved their tool was capturing a unique psychological signal, uncontaminated by surrounding variables. Let's throw a real-world scenario at you, the listener, to really test this concept. Imagine you are a graduate student. You just developed a brand new, highly sophisticated self-report survey designed to measure the construct of physical risk-taking. You need to build a case for criterion validity. What are 3 real-world behavioral criteria, things that happen outside the laboratory, that you would hypothesize your survey should correlate with?
Consider the behavioral footprint of a physical risk taker. Like, what occupational choices do they make? What recreational activities do they pursue? What are the inevitable statistical consequences of their lifestyle?
If your survey is valid, you would expect high scores to positively correlate with a history of extreme sports participation, like skydiving or free climbing. You might expect a positive correlation with the frequency of speeding citations on their driving record. You could even look for a correlation with the total number of emergency room visits or broken bones over their lifespan. If your abstract survey accurately predicts those concrete, real-world criteria, your claim to validity is incredibly strong.
Absorbing all the nuances of reliability, validity, and Stevens' levels of measurement can feel like navigating a really dense philosophical maze. But these concepts are not abstract torture devices invented by professors. They are intensely practical tools.
Which brings us to the final act of the chapter, and perhaps the most important for a student about to start a research project. Practical strategies for the student researcher. How do you take these lofty methodological concepts and actually deploy them in the real world?
Well, the text provides a pragmatic 4-step operational sequence. Step 1. Conceptually define your construct. Do not rely on intuition. Dive into the existing literature and establish the exact boundaries of your variable. Step 2. Operationally define the measure. Decide the specific mechanism you will use to generate numerical data. Step 3. Implement the measure with human participants. And Step 4. Rigorously evaluate the resulting data to confirm the mechanism functioned correctly.
Step 2. The operational definition forces a massive decision. Every researcher, from an undergrad to a tenured professor, has to ask, do I borrow an existing measure or do I build my own from scratch?
The consensus in the field is almost universal on this. Borrow whenever scientifically possible. Utilizing an established measure provides an immense logistical advantage. The grueling work of proving test-retest reliability, inter-rater reliability, convergent validity, and discriminant validity has already been published by other scientists.
Saves so much time.
Furthermore, using a standard tool allows your findings to be directly compared to decades of previous research.
So if my study uses the Rosenberg Self-Esteem Scale, I can directly compare my cohort of 2026 psychology students to cohorts from 1995, because the operational definition is identical. If I invent my own scale, that historical context is severed.
Navigating the sheer volume of existing measures can be daunting, but the text points out several critical databases. PsycTests is a massive repository alongside the Mental Measurements Yearbook and the Directory of Unpublished Experimental Measures. These resources allow you to search for established tools the same way you search for journal articles.
But occasionally, reality forces a compromise. Let's say I am running a massive survey, and I want to measure the big 5 personality traits as a secondary variable. I know the standard personality inventories can be hundreds of questions long. If my participants only have 5 minutes total, I can't use the gold standard tool. I have to adapt.
Right. In those constrained environments, researchers utilize validated short-form measures. The textbook highlights the TPI, the 10-item personality inventory. It attempts to capture the essence of all 5 broad dimensions using only 10 carefully selected questions.
Wow, just 10.
Yeah. Now, will the TPI provide the exact same nuanced reliability and validity profile as a 300-item assessment? No. But it represents a mathematically sound, practical compromise when time is the ultimate limiting factor.
What happens when you hit a dead end, though? What if your specific research question is so novel that an established tool simply doesn't exist? You have to build.
True. But even when forced to build, the most elegant solutions often involve adapting existing proven paradigms rather than starting from absolute zero. The textbook provides a brilliant example regarding the Stroop task.
Oh, the classic Stroop task is a staple of cognitive psychology. For those who don't know, a participant is shown a word, like RAD, but the word itself is printed in blue ink. The participant is instructed to vocalize the color of the ink, ignoring the actual word.
Right.
It measures cognitive interference. The brain automatically reads the word RAD, which interferes with the conscious effort to say blue, resulting in a measurable delay in reaction time.
It is a flawless behavioral measure of cognitive load. Decades later, clinical researchers investigating social anxiety realized they could hijack this proven cognitive mechanism to measure an emotional construct. They developed an emotional version of the Stroop task. Instead of using color words, they used socially threatening words like stupid, foolish, or awkward mixed with neutral words.
And the mechanism remains the same, right? The participant just has to name the ink color.
Exactly. But the researchers discovered that individuals with high levels of social anxiety exhibited significantly slower reaction times when naming the colors of the threatening words. Their brains were involuntarily snagged by the emotional threat of the word stupid, creating a massive cognitive interference effect.
That is so smart.
Mm.
The researchers didn't invent a new way to measure reaction time. They brilliantly adapted an established cognitive tool to illuminate a clinical pathology.
Yeah.
It is a masterpiece of operational design.
Really is.
Let's assume you've built your tool. Step 3 is implementation. And the textbook delivers a severe warning here. Do not assume your brilliant design makes sense to anyone else. You must engage in pilot testing.
Yes. Launching a study to 100 participants without testing the instrument first is just academic suicide. Pilot testing involves administering your measure to a small, diverse sample of individuals while actively monitoring them. After they finish, you interrogate the experience. Were the instructions ambiguous? Did question number 7 sound aggressive? Did the physiological sensors cause discomfort?
Because participants will interpret questions in ways you never anticipated. A word that seems perfectly neutral to a researcher might trigger a bizarre association in a participant, skewing the data. You have to find those structural flaws and rewrite the protocol before the actual data collection begins.
And that leads to the final step, evaluation. You cannot assume your measure worked simply because it was pilot tested or because it was borrowed from a famous paper. You must evaluate its performance within the specific context of your active study.
Let's pull this entire conversation full circle to illustrate that. Think back to the McDonald and Martineau study we discussed in the opening hook. They were investigating unprotected sex, self-esteem, and mood.
Their experimental design required them to induce a negative mood in half of their participants by instructing them to ruminate on negative thoughts. But they couldn't just assume the participants actually followed the instructions. They had to evaluate the manipulation.
To do that, they administered a mood measure immediately after the negative thinking exercise. They used the measure as a manipulation check. The resulting data confirmed that the experimental group scored significantly lower on the mood scale than the control group.
And that single evaluation accomplished 2 crucial goals simultaneously. First, it empirically proved that their psychological manipulation was successful. Second, it provided immediate concurrent validity evidence for their mood measure. It successfully detected the very real emotional shift they had engineered.
And what if the data had looked chaotic? What if the group thinking negative thoughts reported feeling ecstatic?
Then the scientific process halts. You have encountered a fundamental failure. Either your manipulation instructions were ineffective or your measurement tool is broken. You cannot proceed to analyze the primary research question regarding sexual intentions until you diagnose and repair the methodological failure.
The reality of psychological research is that it is a constant, iterative process of calibration and refinement. The numbers only matter if the tools are true.
It demands an obsessive dedication to structural integrity.
We have navigated an immense conceptual landscape today. Let's integrate these pieces before we conclude.
Good idea. We established that psychology grapples with invisible constructs, necessitating precise conceptual definitions. We bridge the gap to reality through operational definitions, utilizing self-report, behavioral, or physiological mechanisms, ideally employing converging operations to cross-verify our findings.
We examine the mathematical skeleton of NOI, or nominal, ordinal, interval, and ratio scales, and how the presence of equal intervals or a true 0 point dictates statistical reality.
And finally, we differentiated the internal consistency of or between observers from the external accuracy of validity, requiring face, content, criterion, and discriminant evidence.
Now, before we sign off, we want to leave you with a final provocative thought. We've spent the hour discussing measurement as a sterile academic exercise, but these principles are actively shaping the reality you inhabit right now.
Consider the digital architecture of the modern world. The algorithms driving your social media feeds are engines of continuous psychological measurement. The tech industry refers to their primary metric as engagement. They collect ratio-level data on your scroll speed, ordinal data on your reaction choices, and behavioral data on your click-through rates. But what psychological construct does engagement actually represent?
Are they measuring your genuine intellectual interest? Are they measuring your joy? Or are their operational definitions, time on screen, clicks, shares, actually converging on the construct of compulsion and behavioral addiction?
As a student of methodology, you must ask, how valid are their operational definitions? If an algorithm defines valuable content exclusively through the behavioral measure of attention duration, does that operational definition align with the conceptual definition of a healthy psychological life? The tools of psychological measurement are not confined to the laboratory. They are the underlying code of the attention economy.
The methodology you are learning in Chapter 4 is the exact methodology being used to measure, predict, and influence your behavior every time you look at a screen. That is the power of operationalizing the invisible.
It is a profound responsibility.
As a final reminder, this deep dive provides the conceptual architecture, but it does not replace the granular detail within your textbook. Go read Chapter 4. Engage with the practice exercises. Challenge yourself to draft an operational definition for an abstract concept like hope or cynicism.
The science of psychology only advances when researchers relentlessly question how they know what they claim to know.
Keep questioning the measurements around you, and we will catch you on the next deep dive.